Today we're going to talk about the area of a regular polygon. And if you remember, a polygon is any shape that has three or more sides. It has to be closed and the sides have to be straight. A regular polygon, a regular shape has congruent sides and congruent angles. That makes it regular. In this example over here, you have a regular six-sided shape, which is a hexagon. And you can see each side is the same length, and each interior angle is the same measure. Now, some terminology, the center of that shape is known as the center. All right? From the center to the vertex, these blue dashed lines here, those are each called a radius, or radii for plural. And from the center down to the midpoint of one of the sides, and it's perpendicular with the side, is called the apothem. Okay, the apothem is the perpendicular distance from the center to a side. All right, now the apothem will cut the side in half, just for future reference. So our first objective is to work with the angles that are created with radii and the apothem. So let's talk about angle 1 over here. All right, angle 1 is created by two radii. This is called a central angle. To find the central angle, we're going to simply take 360 degrees and divide it by the number of sides. In this case would be 5. So 360 divided by 5 is 72. Angle 2 in this diagram is created by the apothem and a radius. All right, and this is going to simply be the central angle divided by 2. So in this case it's 72 divided by 2, which is 36 degrees. Angle 3 over here, angle 3 is part of this triangle, and I know triangles add up to 180. So I'm going to add 90, and what I got for angle 2, which was 36, add those two together and subtract from 180. So it's going to be 180 minus 126, and that should give me my angle 3, which is 54 degrees. Okay. Same thing goes with example B. At the right, we have a portion of a regular octagon. An octagon is 8 sides, and it has radii and apothem drawn. Find the measure of each numbered angle. So let's start with angle 1. Angle 1 is created by 2 radii. So again, that is called a central angle. So I'm going to take 360 and divide that by the number of sides, which is 8. 360 divided by 8, I believe, is 45 degrees. All right, angle 2. Angle 2 over here is created by the apothem and the radius. So that's simply the central angle, which I just got was 45 divided by 2. And if you do that right, you get 22.5. And angle 3, well, angle 3 is part of this triangle, which is going to be 90 plus 22.5, and then I'm going to subtract that from 180, because all triangles add up to 180, and if you do that right, you get 67.5 degrees. So there's example 1, finding the angle measured inside of a regular polygon. Okay, next we're going to talk about how to actually find the area of a regular polygon. All right, Theorem 712 states that the area of a regular polygon is half the product of the apothem and the perimeter. So here's our formula for area of any regular polygon. Okay, that goes all the way up to, 500 sides. As long as it's regular, we can use this shape, or this formula. Okay, now to be clear, A in the formula stands for the apothem. P stands for the perimeter. Okay, P is the perimeter. Now remember, to find the perimeter of any regular shape, you're going to take the length of the side and multiply it by the number of sides. That will give us the perimeter. So here's our first example. We have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a decagon, and it's regular. So our area formula for that would be 1/2 apothem times perimeter. So 1/2 apothem times perimeter. The apothem is right here, 12.3. And our perimeter, each side is 8, so it's going to be 8 times the number of sides, 10, which gives me 80. And now I can calculate that out. 0.5 times 12.3 times 80 is 492 inches squared. All right, so that's an example of where they pretty much give you all the information you need to know, and the only thing you have to do is this work right here to find that perimeter. Okay? Again, that's the side times the number of sides. Okay, the next example, we have example 3 here. It says the side of a regular hexagon is 16 feet. Find the area of the hexagon. Okay, so first thing I want to do is let's get a regular hexagon going here. Do I even have a hexagon in here? Here we go. Alright, so let's try to make a regular hexagon. That looks good. Move this over here. Alright, according to the given information, it says the side of a regular hexagon is 16 feet. So that means all of these sides are 16 feet because it is a regular hexagon. Hexagon is 6 sides. Alright, so let's see. We have area equals 1/2 apothem times perimeter. Alright. The apothem, which is from the center down to the side, perpendicular with that side, is an unknown value. I'm going to have to figure out how to get that. The perimeter we just did was the number of sides times the side length. So the side length is 16, and there are 6 sides. So 16 times 6 would be 96 for the perimeter. So the only thing I have to find here is the apothem. So the first thing I'm going to do is I'm going to draw a radius. Okay, this is a radius. And I'm also going to figure out what this angle is right here. Now this angle is half of a central angle. So I'm going to take 360 degrees divided by the number of sides, 6, and then I'm going to divide that by 2. So 360 divided by 6 and then divide by 2. Alright, and we get 30 degrees. Okay? Now if this is 30 degrees, this is 90 degrees, that makes this 60 degrees. Okay. In here we have a 30, 60, 90 right triangle. So let's bring that out and remember how that triangle works. Okay? Across from the 30-degree angle is what I like to call the short leg. Across from the 60-degree angle is the long leg. Now to get that, we take the short leg times radical 3. The hypotenuse is always double the short leg. Okay, so this is our diagram. Now, the bottom of this triangle is going to be half of 16, 8. Okay, so this represents the short leg. So from the short leg, I can get the long leg, which is across from that 60-degree angle, and this, coincidentally, is our apothem. So it's going to be the short leg 8 times radical 3. So we have 8 radical 3 as our apothem. Now I have enough information, I can go ahead and calculate this. I'm going to leave this in radical form, so I know my answer is going to have a radical 3 on the end of it. And the only thing I want to calculate are these constants. So 0.5 times 8 times 96, and we get 384 radical 3, and this would be feet squared. So in this example, we used a 30, 60, 90 right triangle to figure out that missing information. Okay, let's move on to another example and find the area of this shape to the nearest tenth. Okay? Alright, in this shape, alright, let's write out our formula. Area equals 1/2 apothem times perimeter. Let me give myself some room here. Alright, the first thing I notice is that I have one side is 18. So I'm going to take 18 and multiply it by the number of sides here. And this is an octagon. And an octagon has 8 sides. So 18 times 8 would be 144. There's my perimeter. Alright, what I don't have is the apothem. So here's my apothem, and I don't know what that is. The bottom of that triangle is half of 18, so that's 9. So if I took that triangle out and looked at it separately, maybe that'll help me out. The bottom is 9, this is the apothem, and this is 23.5. Now I know 2 out of the 3 sides, so I don't even have to mess around by finding this angle. I know I can use the Pythagorean theorem to figure this out. Once I have my apothem, I can plug it into the formula and get the area. So I'm going to make A my A, 9 will be B, and C must be the hypotenuse, so we have A squared plus B squared equals C squared. I'm going to go ahead and calculate this out. This will be 81. 23.5 squared is 552.25. I'm going to subtract 81, and that gives me 471.25. And finally, I can square root that. Now we get quite a long decimal here. We get 21.708293335, and it probably goes on forever. This is our apothem, so I'm going to plug this in up here. Now, I'm going to calculate this. So the last thing in my calculator was this long decimal, so I'm going to leave that in there and hit times 144 and then divided by 2, and I get 1,562.997, and it keeps going. Now this says round to the nearest tenth. My 10th spot is my 9. This is going to bump up because of that 9 to a 10, so my final answer is 1,563 square feet. So you can see some of these problems on the previous example here. Previous example, we used a 30, 60, 90 to figure that out. Okay, in this example, we used the Pythagorean theorem to figure out our missing piece. Okay, so hopefully that helps you guys out, and have a good day.